Hi Panthers, I'm making this video on Friday afternoon, the 25th of October 2019. We had a class meeting today, and in that class meeting we were working on factoring to solve quadratics. And as you left, several of you mentioned that you felt like it would help to have a refresher on some of those ideas. So I put together this screencast to try and help you out here. Now in this screencast I'm going to try to model the box method factoring technique that I showed off in class today, simply because I think it could become the most effective and most efficient way for you to do this. And to do that, what you need to know first is that I teach my Algebra 1 students to multiply with the box. So if they're going to multiply x plus 5 by x minus 7, I will teach them to set up the two binomials along the outside edge of this box, this 2 by 2 box. And then to multiply, simply to multiply each like every row and column. So x times x is x squared. X times negative 7 is negative 7x. X times positive 5 is positive 5x. And negative 7 times 5 is negative 35. And of course, that's what you're doing when you do FOIL or whatever method you use. And then I'll ask the students to write their answer by combining all the like terms in this new polynomial expression. And what they'll pick up on is that they can almost always combine the like terms in the middle, the diagonal. You know, negative 7x plus 5x really makes a negative 2x, doesn't it? So the answer is something like x squared minus 2x minus 35. And a similar process would work here if I was going to multiply 2x minus 3, 2x minus 3 by x minus 4. It would look something like this. 2x times x is 2x squared. 2x times negative 4 is a negative 8x. Negative 3 times x is negative 3x. And negative 3 times negative 4 is positive 12. And again, we're in another situation where these terms are like terms, so they can be combined. And when we write our answer, we'll write an answer something like 2x squared. This would make negative 11x plus 12. So when I teach my students in Algebra 1 to factor using the box method, I ask them to think about the multiplication process backwards. Factoring, of course, is writing that trinomial as a product of two binomials. So my students, after experiencing multiplying with the box, they know to think that, well, x squared is what you get when you multiply those first two terms together. And the positive 12 is what you get when you multiply the two numbers together. And they also know that they need to set up the outside edges here so that whatever they multiply together, the two middle terms create a sum of negative 7x. So these students will figure out quickly that they know that they can put x and x here because x times x was x squared. But they'll have to think for a second about which numbers to pick to multiply to get 12 that add up to negative 7. So I do teach them to list out the factor pairs of this number, 1 and 12, 2 and 6, 3 and 4, and to look at that set of factor pairs to find the pair that adds up to 7. Ah, there it is, right there. I need 3 and 4. 3 and 4. Now to make the signs work out, to make negative 12, to make positive 12, but to make a negative 7x in here, I need to make both of those signs negative signs. So we'll have negative 3 times x, which is negative 3x. Here we would have negative 4 times x, which is negative 4x. And those middle terms do in fact add up to negative 7x. So what that tells me is that the factors I need are this times this. X minus 3 times x minus 4. Here's another example. X squared plus 5x minus 36 we want to factor that. So I know that x squared belongs here. I know that negative 36 should go here. I believe I can tell you with confidence that I've got an x times an x to make x squared. I don't know yet which factor pair that multiplies to 36 I'm going to use, but it might help me to list out those factor pairs. 1 and 36. I've got 2 and 18. I've got 3 and 12 as an option. I've got 4 and 9, or I could even use 6 and 6. But I need to find the pair that would have a 5 somehow. You know, I know the signs need to be different too to get negative 36, so I'm really looking for two numbers with a difference of 5. There it is. 4 and 9. 4 and 9. This would make 4x here. 9 times x would make 9x. But I need to make sure one of those signs is negative. Which one needs to be negative? If I need a positive 5x, I better make it positive 9 and negative 4. So how about negative 4 here and positive 9 here? And it works. 9x minus 4x is 5x. So our factors are x minus 4 and x plus 9. Now these two examples are a little bit different and they're more difficult because of, as we talked about in class today, they're not simply an x squared term. There's some real number x squared. A is not 1. But this setup will still solve these factoring problems. Let me try this one. 3x squared plus 16x minus 12. The 3x squared belongs here. And I know that the negative 12 belongs here. Now, this isn't as simple as just x squared, but I do have the advantage of knowing that there's only one set of whole numbers you can multiply to get 3. That's 3 and 1. So I'm thinking that this should be like 3x and x. You know, there's no other option. There's no other real number option here. I should say there's no real whole number option here other than 3 and 1. I do still have some choices to make with my 12. It could be 1 and 12. It could be 2 and 6. It could be 3 and 4. This is a little more complicated because what I need to find is positive 16. So you got to be really unafraid to do a little bit of guess and check here. I'll try, let's do 4 and 3. 4 and 3. This would be 9x. This would be 4x. I know the signs have to be different. That's not going to get me anywhere close to 16x. So let me try something else. Let me try 2 and 6, and I'll just put the 2 here and the 6 here. 6 times 3 would make this an 18x. You know, I think this is the one. 2 times x is 2x. And since I know I need the signs to be different, I need to positive 18 and negative 2. So 3x times positive 6 is positive 18. And x times negative 2 would be negative 2x. So I think we found the numbers we need. Essentially, this is just a puzzle to solve. You're finding the correct pieces to put in place to make the square say exactly what your original trinomial said. My two factors here are 3x minus 2 and x plus 6. Let's do one more. We need 12x squared plus, 37x plus 21. The difference here is that I have both an A and a C that have possibilities. So my options for 12 for the first terms are 1 and 12. Or it could be 2 and 6. Or maybe 3 and 4. But I have options over here for the C term as well. It could be 1 and 21. It could be 3 and 7. I guess that's it. So here I've got to be really not afraid to do some guess and check. Let me just try 2x and 6x and see if that gets us anywhere. And let's try maybe 7 and 3. This is 14x. That's 18x. 14 and 18 is not 37, so that's not it. Let me maybe try the other order. Let me put the 3 up here and the 7 here. So if I put the 3 and the 7, this is now 6x. This is 42x. Those don't add up to 37x either. That's not it either. You know, maybe it's not 2x and 6x. Maybe I need to try a different set. Maybe I need to try 3x and 4x. Let's try it. Let's try 3 and 7 here. Let's do 7 and let's do 3. This would be 3 times 7. That's 21x here. 3 times 4 would make 12x. 21 and 12. No, that's not 37. I wonder if it's the other way. Let's try the 7 here and the 3 here. 4 times 7, that would be 28x. Oh, that's it. 3 times 3, that's 9. 28x and 9x is 37x. That's the one I need. 3 times 3 is 9x. 4x times 7 is 28x. I need the signs to be the same, and they need to both be positive. So let's get the signs on there then. We've solved it. We figured it out. My two factors are 3x plus 7 and 4x plus 3. Okay, as I told you in class today, there is a practice set available for you on Delta Math. It's titled Practice for LTO 13.4, and it's listed optional. This is obviously not something that's due. I'm not going to put a score in RDS for this. I just want to make sure you have available practice to continue working on factoring to solve quadratics if you need it. Good luck, let me know if you struggle, and thanks for watching.